Hello, my name is Paul, and this is the Mythruna weekly live stream, where I code some aspects of Mythruna while you guys watch and chat, and I answer questions and so on. Last week we worked on AI perception, and we'll kind of be continuing that work this week. I'll show you what I did in the interim time, and we'll get started. Before we get too far, let me thank the patrons. Yep, feeling the money pinches right now because it's the new year and new insurance deductibles and so on. So thanks a lot, guys. I really appreciate it. All right, let's go ahead and get started. Yep, there's the Drost effect. Looks like we're good there, so we'll minimize that, bring this guy down. Oh yes, this is the reminder that up in the upper left corner, you can see is the link for the test engine build and the password. If you go to that link, there'll be a link to the Discord and a link to a bunch of the binaries you can download for Windows, Linux, and platform independent, which for anybody who has a weird flavor that doesn't work with those other two. All right, so before we get to, let's go ahead and get started. Yeah, the extremely frustrating thing about creativity is that it does not work on my schedule. I've found that to be true for the last month, where I think about a problem and when I'm sitting in front of the computer, I can't think of the solution, but as soon as I walk away, there it comes. Okay, so last week we were working on perception frustums and trying to get those lined up correctly with the AI, with the mobs. I did get that working, and so I'm going to show that, and then I also set up different size frustums for the different types of mob, so people can see a different distance than dogs and Gafen and so on. So we shall take a look. And I'll show you a little bit about what I worked on over the week. There's two main thrusts for this particular next release, which hopefully I can get done by the end of the month, but we'll see. One is to get these AI behaviors and perception stuff working, so that the dog and the Gafen and stuff react. And the other one is to have tool interaction with the blocks, so that when mostly what we use right now is the build wand, and that instantly removes blocks, instantly places blocks. But for some cases, it will be better to chop things or hack things with the pickaxe. For example, if the way the plan goes now is if you want to actually mine for minerals and things, you're going to have to use the pickaxe, whereas the build wand is just sort of a way to suck up stone and remove it. But ultimately, to chip out gems especially, you'll need to use a pickaxe and chip away at the rock. So, I mean, I need to work on that, but that's a topic for a future thing. But I did work on, if I'm holding the axe and it's swinging, I know where it hits. The blue lines are sort of the contact points, and then the yellow lines here are debugging sort of the amount of force I hit, which means if I walk up to it like this, I get like all kinds of, because that axe is swinging too and hitting it. And so I need to disambiguate hits from just glancing it, because I'm turning, versus hits where I'm smacking it. Part of that's going to be detecting that there's more force, and so these are really just velocity lines right now, but when I'm swinging the axe, that's with a lot more force than when I'm just walking around and bumping into things, which currently it's swinging faster, so it looks like those are higher velocity. But anyway, in this case, the contact knows what part of the axe, whether it's the sharp blade or the heftier part. It knows what part hit the tree, and you can see it knows what angle. So here, when I hit it like this, all the angles, the force angles are directly into the contacts, and so that would automatically make that, and it's all the sharp edge, so that would automatically make that a sharper hit than when I just bump into it like this. You see those force lines are orthogonal to the contacts, so that would be almost nothing. I mean, it might scrape some of the bark off, kind of thing. But anyway, that's what I worked on during the week, because to get that done, I actually had to implement the sphere or the cylinder colliders, which did not work before. Let me turn off, well, I can't actually turn off, but so before, if you had two cylinders like this, you couldn't walk between them, but now you can because proper cylinder colliders. So that's good. That took a couple days, or a day or something. But let's get back to the topic at hand. I'll switch over to the test wand so that I can create some NPCs. I thought I had some nearby, but maybe I deleted them. Alright, so let's go down here, and we'll put a dog in this little field over here. And I'll show you what I ended up with. So, oh, yeah, there are some over here. So there are a couple of people. I'm going to go ahead and place a dog and let him walk around, and then I'll turn on the probe debug, which is where I switched the... Yeah, hopefully, right? So anyway, now the frustums are all lined up with the eye lines, even as the things animate. Like if we can get the dog, let me put another dog down and we'll see that when he's standing still, as he looks around, even with his animations. And like my dog, I patterned this animation off, has this little left head tilt, and so when it's sitting in idle, it tends to like lean to the left, which I think is cute. So anyway, as you can see, they're looking around, and so that's all synced to their head and eye movement. What we're going to do today is take that and get the results of those queries and decide what's entering frame and what's exiting frame. And before we do that, we have to set up signal handlers and things, and that's what we're going to do, and that's what I started coding right before the live stream, is to try to set up that some of that infrastructure. But I'll talk about the way that works. I know we think this is cool. Little doggies running around, and lots of debug, which is problematic. We're going to have to squelch some of that. But let's talk about the current hacked in AI, where I've hard-coded big behaviors that launch other behaviors. That's what we've got right now, and I have one for the Gaphin, one for the dog, one for the NPCs, and so on. They tend to be organized into 3 parts. One is check for interrupt conditions. Is it 2 R's? Yeah. And set new behaviors. 2, if already busy, return. And 3, check for things to do when otherwise idle. Okay, so that's the way they were kind of hard-coded together. And if we looked at the brain for like the, I think the dog has the simplest one. You can see in its update, it checks to see if it should be, if somebody talked to it and it should face them, or if somebody pet it and it should be following them. Otherwise, if the current behavior is the default behavior, i.e. we're just doing whatever the default behavior is, then we return. Or if it's not the default behavior, we're doing something other than the default behavior, then we just return. Otherwise, we go and we check these other things. Am I far away from home and it's been too long? Then I'll go home. Otherwise, I'll do some random things, or maybe maybe I'm already heading home or whatever. Oh no, if it's no home, I just sit still. Random roll, I do idle things. Otherwise, every now and then I head home, and so on. But the new way, I need a way to programmatically interrupt things with signals. Like somebody says something, somebody hits you. We bump into something while we're walking, or we see something new in our field of view, that kind of thing. And so new signal-based AI will kind of be like a state machine. I tend to kind of combine state machines into whatever they call it, like context trees. There's another behavior trees, that's what it is. And so my behaviors are kind of like the root nodes of behavior trees, but I also like the interruptible signals of a state machine. So what it will be is that a brain will basically have signal handlers, and the current behavior. Okay, so when a new signal comes, new signal, it gets added to the queue, added to the signal queue. And so then every update we go through the queue, see if we can handle that behavior or that signal, and then potentially switch behaviors. And then behaviors themselves, behaviors are also signal handlers. So you can so the idea being that it really is kind of like a state machine at this level, although a behavior is a signal handler, so it can be its own state machine, which is kind of like so it can have its own interrupts and so on, which is kind of like a behavior tree in the sense that that behavior could have sub behaviors and so on. But there's some implications to this approach, meaning that basically every current behavior is also a signal handler, which means that when we see if we can handle that signal, the first thing we check is the current behavior, which means that the current behavior can override the default handling of a signal. So maybe by default, an NPC will turn to somebody and talk to them whenever they get talked to, right? But probably we don't want that when the NPC is running away from a bear. So if he's in the flee behavior, chances are he's not going to stop to talk to anybody who happens to click talk on him, right? So when when that run away from the bear behavior is engaged, it will override some of the default signal handling, like the talk handler and some other things, to implement self-preservation, that kind of thing. I think that a lot of behaviors can be implemented a lot of visible behaviors can be implemented this way logically without adding a whole bunch of conditional statements in and stuff. We'll see. But I think this is a good foundation, and it sets me up to be able to get rid of these hard-coded default behaviors, because in this new form, okay, so that's the other thing. In this new form, signals are things like somebody talked to me, I saw something, I bumped something, but also I'm idle, a heartbeat, periodic heartbeat. So like these kinds of updates go away in the sense that these three different sections, they go away because by default we're just going to do whatever the current behavior is, and if there's no current behavior, we'll do the default behavior, because everything else will come through as a signal, even a periodic heartbeat, which lets me check and see if I'm hungry or thirsty, or if I should be going to my job, etc. Or if I'm idle, which means that that's called whenever there is no current behavior, which is what we do in these second halves, where I'm rolling the dice to see if I wander for a little while or whatever, or head home. That would be done on the idle signal. So we end up with a case where these behaviors can run independently. Sounded one interest variable. Yeah, I mean there's lots of things going on here. But anyway, there's a bunch of different kinds of signals that'll happen, and one of them is idle, which I think is kind of a cool way of handling this sort of dropout here. And so this kind of root level update goes away because the brain handles everything. And we'll see how far we get into this, because what I plan to do is we're going to see. I started implementing the signal handler interface, a composite signal handler that'll handle anyway. And what I plan to do is convert one of these over to the new way and see how that goes. And if it goes quickly enough, we can start implementing the perception set, which essentially we'll check the perception set every frame, and if it generates things entering and exiting our field of view, we'll turn those into signals. So right now there's like a signal which can contain some kind of payload and a type, so that's one of these, talked at, saw something, whatever, or entered view, exited view, that kind of thing. And then there's a signal queue, which handles keeping track of unique signals in the order we received them. And then each signal handler can generate a reaction or return null if it doesn't care about that particular signal. And so we can build up these sort of lists of handlers, and they all coordinate together and so on. And then the composite signal handler, which is sort of the way to add a bunch of handlers to the brain. And so I just got all that to compile with all of its fancy generic typing and stuff. So let's get started. I kind of want to have, I believe I'm going to want to be able to test this in maybe some groovy unit tests before, but let's see. I don't want to have to run the game every 5 minutes just to test things. Then again, I think rapidly the frameworky stuff sort of works itself out. It's straightforward. And so, all right. Well, first, let's just start. Let's just see how far we get. So we're going to add that behavior extends signal handler. All behaviors are signal handlers now. That's going to create a whole bunch of problems because we've got all these behaviors implemented already. And I don't think I ever made an abstract behavior. Oh, I did. Rock on. So then we can just steal this. If all of the behaviors extend abstract behavior, we may get this for free. So I do that usually. I make an abstract version of the interface to protect me from future changes. And so this will always return null. They do nothing. They do no interrupt handling by default. So yeah, this is kind of like I actually in my original design called this interrupt. So a particular behavior can be running and potentially you interrupt and it returns a new reaction. Wow, I've been talking long enough that I hadn't drank any of my Pepsi yet. Okay, so let's see, behaviors. So these implement the behaviors directly, which means they will all need something similar. And I kind of want, maybe they should extend the default, and I kind of want maybe the abstract Okay, so first of all, I may have stupidly done this, but this means signal handler is a generic typed but so maybe we'll see if it lets me get away with this. Oops. Let's so it's going to complain about 100 things. Composite. Yeah, so hold on, before I start adding this stuff, let's just leave this. Let's make all of these extend abstract behavior. Oh, that's because abstract behavior wants a brain. Okay, so we'll do super null. So I'm just trying to fix these to make my refactoring job a little easier. It's funny, during the week, I use fancy IDE. I use IntelliJ, and yeah, so that one actually does take a brain. All right. Follow behavior, does it extend? It does. All right, let's see what breaks when I compile. But sometimes when I'm doing these kinds of refactorings, I find that I have, like, over the years developed sort of a process. Yeah, it's not going to let me do that. Can I just leave it out and deal with all the stupid warnings it's going to give me? Oh yeah, that's one of the reasons I did not. Okay, so aha, abstract behavior. Yeah, so if I do that, I have to do this. They need to okay, so hold on. What's it complaining about? Okay, that should be gone. Brain is gonna brain's gonna complain about a lot of stuff. Hold on. Okay, we're getting closer. Actually, brain's gonna complain about a lot of stuff. Behaviors. Okay, those are tucked away now, so they can't. They have to do on start. Okay. This is what I should have done before the live stream, but you get to watch me refactor on the fly. This is kind of fun too, right? Oops. On start is running is fine. On stop is the other one. So if I fix one of these, then I should be able to see if it does what I want. To reduce those errors, should get rid of 2 of them. And I can do the same. Yep. Right, we had 4 before, we have 2 now. Okay, yep. So do the same thing to this behavior. And we're drilling in on refactoring. So hopefully this is like educational that I'm refactoring on the fly. I'm trying to support both modes of operation at the same time. Yep, so brain is implementing a lot of these, but does not extend. Okay, so we will steal this for now, because we've got these this is fine. We've got these stupid default behaviors that I'm working to get rid of, right? So temporarily we'll hack in this wherever we find a place for it. Those are all abstract behaviors. Those are good. We got one more, at least one more. Okay. Oh, the butterfly. Butterfly. Okay, so we should be able to compile. We're going to get some type warnings at some point, but I almost don't really care about the generic types. I put them in by habit, and then they usually end up taking half the time to get them sorted out. Okay. So actually we could pick the butterfly, except for its behavior is so simple, I'm not sure we would know whether it was working or not. So anyway, the brain is going to need a composite handler and we're going to need actually, for now, I'll just use the raw signals. I was going to, the reason I did it this way is because I was going to extend signal to implement, one for entity IDs, one for contacts, that kind of thing. But we should be able to then, we need a signal queue. Oops, signal queue. Signals equals new signal queue. Okay, somebody's going to warn us that we're doing unchecked creation, right? Nope. Okay. It's all good then. Now I think in update we'll set up some of the signal handling behavior. Oh, well, see, I even called it the method signal. That's nice. So then we can just come in here and oops, signals, add. I think I just called it add. Yep. Signals, add, new signal. Talk, and then who talked converser. Okay. And then we'll do a stopped talk stopped. Yeah, I don't know what to call it. Oh, yep, converser. Yep. Converser. Good. And we say pet, signal pet. And we got the petter. And reset's fine. So these are some signals we already deal with, and they'll make good tests as we figure this out. So then somewhere in here we can, all right, let's set up the, yeah, see, I called it a global behavior. It's going to become the default behavior. So the first thing we want to do is on update, we want to go through the existing signals, right? Let me check my design document real quick. You get to see the craziness that is my approach to design. Yeah. So on update, yeah. So something like this is what we end up wanting. But really the behaviors are involved in here, so let me just keep my notes here for a second. So we're not gonna do the heartbeat for a second, for right now, but we do want to say while signals, well, not signals is empty, grab a signal, poll, and then we want to say if current behavior is not equal to null, then current, alright, I'm going to do this the crappy way for now, but really this should be lumped together. Nope. Okay, so I'm going to duplicate code because, oh wait, no, that's not going to work. Okay. So we were gonna, I know. Okay, generate reaction signal. Oop. What I wanted to do was make another composite signal handler that contained both the default behavior and then the actual composite behavior, which is composite signal handler. But what I'll do is I'll just do that in a method for now. So this is, if anybody has any questions about what the hell I'm talking about, feel free to pipe up. And so then this is where we'll do this. If current behavior is not equal to null, yeah, reaction equals current behavior dot generate reaction signal, and if reaction is not equal to null, then we return that reaction and stop, right? So that's there. And then we set up these handlers, they're like default handlers, it's just signal handlers, and that's what we'll check next. Reaction equals generate reaction. So this is why I was saying if I combined, basically if I combined this logic into this by putting it in the list. Anyway, the issue is that as I add and remove current behaviors, current behavior has to not equal the default behavior. And not equal to null. We only want to ask the current behavior if it's not the default behavior. Like it's a special behavior, then it has special reactions. Actually, just return. Okay, so then we generate a reaction equals reaction equals null. Then we fully ignored that event, continued the next event, else new behavior equals reaction dot get behavior, and if new behavior, new behavior is not equal to null, then set the current behavior. And the reason this is the reason signal handlers don't return a behavior directly is because a signal handler may say, yes, I handle this signal, and you should totally ignore this particular signal. Like when we're being chased by the bear and we get a talk signal, this is the way we override it, by returning a reaction that's not null. So we do actually handle the signal, but then there is no behavior in there, which means we don't do anything with that. We continue on with our current behavior. Okay, so here we would check for heartbeat, add heartbeat signal, process pending signals up to the first time we find one. Yeah, in fact, I want to make it so that as soon as we find a real behavior, as soon as we handle one signal, we break, which lets that behavior run at least once. Yeah, so there's the global behavior. So then, and then, yeah, and that's all fine. And then if we have a global behavior, we update that if the current behavior equals null, set current behavior to null, which sets the default behavior actually. And then we let the behavior update, and then we set a debug. What I really want to do is now, I think, if current behavior equals null, then we would send the idle signal. So we want to signals, add new signal. So how's everybody's week been? Our local bus workers had been on strike, and so I was running my oldest child out to college every day, which is, sort of, depending on the time of day, a half-hour round trip. So that was sucking 1.5 to 2 hours out of my day. That made it hard to work on Mythruna, and that's been going on for like 2 weeks. And they finally resolved the strike. The workers got what they wanted, which is yay, everybody. Anyway, and so they start bus service again tomorrow or today. And actually next week is spring break for the local college, so it wouldn't have mattered anyway. But this week was painful. Next week becomes a lot easier. I hope everyone else is having a better time. Okay, so I think we've got the basic gist of the update loop. And eventually this global behavior thing goes away because it's going to be replaced by the, basically the signals that are, or signal handlers. And then we end up with just a default behavior. And so I think I messed up when I said... Oh no, default behavior. Global behavior is different than default behavior, but global behavior will go away because we're replacing it with this, basically. Okay, so all that should work. And then what we could do... What's the quickest way to test this? The quickest way to test this is to configure let's set up the NPC to have a signal handler new signal handler. Actually, it's only got one method on it. I probably could have just used a lambda. Let's use a lambda. Okay, so log info signal. Okay, and then who the hell was generating all this stupid logging? It's all the perception stuff, right? Probe debug state. Where is it? I mean, this is all normal stuff. Oh, there we go. Player driver, debug shape view state. So if I didn't have the debug states open, maybe it just was dumping so much stuff. Spatial rig type collider info. Creating shape. These are when they were first plopped down. Alright. Let's go ahead and run. If it even compiles. Nope. Warning, warning, I don't care about those. Errors, I do. Cannot find... Oh, add delegate. Okay. Oops, I was already on the line I needed to be on. Add delegate. And who else is complaining? Cannot find symbol. Current behavior. Generation reaction. There's the other one. I knew there was 3. Okay. Lots of warnings. Incompatible type. Bad. Oh, yeah. Where is it? Where is it? Where is it? Where is it? There it goes. Return null. And who else complained? They're all out of those unchecked. I'm gonna get a ton of unchecked. I'll have to sort out the typing later. Okay. So is the signal being delivered? That's what we want to know. And then we'll start trying to convert our behaviors over to signal handlers. Yes, we're still getting a bunch of... Yes, that's all of the contact system. I need to... Yeah, I know what I need to remove to get that... hello, darkness, my old friend. Okay, so we overrode the talk signal. And so I should be able to talk to him and say, never mind. And so I should get 2 signals from that. And it is this... Okay, so the debug view state. I think that shouldn't be running at all because it's not even enabled. Debug. But it's the, wow, that's a lot of, why is it? Oh, all those contacts, every time I move, whoops. Every time I move, every time anything bumps into anything, that contact system is generating all those little debug arrows. So I need, that's what I was working on this week. That's why that's all still enabled. But let's get rid of that for now. So we want to just say we're not going to do anything. If true, return. Excuse me. Okay, so that should get rid of all the chatter. And then in the, so we want to grep brain. So we should have seen some signals. NPC signal type talk with me. I'm entity 22. And then later NPC signals talk stop. And hey, it's getting its signals. Okay. So this gives us an opportunity to replace at least one aspect of the behavior. So we've got this signal here, which we actually could technically use to replace you know, all of the conditionals of this thing, but what we want to do, see, talk behavior. Ah, that was set down here, so we already have it. Ah, nice. Okay. So well, yes and no. Talk behavior. What happened when the old signal came through is we set the add converser on the talk behavior because I was using talk behavior as my cue for that particular signal. That is not what we want now, but I'm trying to keep it. Okay, so what we will do is hack some stuff in here. So talk behavior, add, oh, so wait, first we have to check the signal type. If the type is I'm going to add a bunch of constants for this later. Talk. The type is talk. Then we're going to add the converser and set current behavior, talk behavior. So eventually these, that's the other thing is, the signal maybe should have the brain in it that's initiating the signal. Anyway, I'll work that out later. I'm trying to replace the behavior and then I'll formalize this all. Okay, so else if what did I call it? Done talking. Talk stop. Okay. And we'll just repeat all that. And then instead of set the current behavior to null and remove the converser just to clean it up. And now I should be able to find usages of talk behavior and get rid of them. But we will do this too. Since we have the access, did we turn it off too? We never turn it off. Okay, cool. I'm just going to comment out everybody's. Oh, the excited thing. I'll worry about that later. So we don't want to do this anymore. Okay, so we just broke talking for the dog. It will only work for the NPC if it works at all. But basically we replaced all that code up there with this little guy, which is event-based, and I think that's cool. Okay, so let's just check to see if that worked. Let's just check to see if that will compile. Oh, that's right. I'm being an idiot. We don't set current behavior anyway. That's interesting. We can't really do that either. What we can do is return new reaction talk behavior. And we don't really do anything special for talk stop is not an event we do anything special for. We did before, but we don't now. Or we return null. Okay, so then what was it complaining about? Let's try again. Oh, converser. Yeah. So this is actually entity ID signal. Oops, signal get value. Okay, let's try again. If you are new to the channel, please consider liking, commenting, subscribing, etc. And up there, if you missed it earlier, the download for the January release of the engine's up there. That's also where you can join the Discord, which is a pretty good group of people on the Discord. I like it. All friendly folks with an interest in Mythruna. Happy Friday, Lando Calrissian. How's Cloud City of Bespin doing? Okay, so then if we come up here, we should still be able to talk and have them face us. Yep, they still faced us. Yay. So the facing is the behavior that they do when they're talking to us. So we go over here, we say, talk. Hey, it worked. Wrangling with spring tests. Nice. Yeah, destroyed. Depends on. It was in a galaxy far, far away, long, long ago, in a galaxy far, far away. Okay, so we've implemented the talk behavior. Um, it's interesting that I added a follow behavior, but the NPC. What I let it, so we could pet the NPC. No, I never added a pet action. That's why. Okay. Um, but we could fix the dog as well. So eventually these would be configured externally, not hard-coded in this method, but we're getting closer. Whenever we can put all the code into one of these if branches, um, that means that means we could easily externalize it as configuration on the brain. And so let's also go ahead and add a behavior for petting. So dog signal if pet equals da ba 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 ba. Yep, and we'll add one of those for the Gathan too in a second. So yeah, is it already time for spring tests? Do you go to school then? Ba 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 ba. My older child is on spring break next week, which is unfortunate because my younger child is not. So it's not like we can do anything special. Yeah, Java Spring. The pet. So we already added the signal for pet. And this. Okay. So the dog, when you pet it, we want to get the Java Spring tests. Oh, I get you. Like spring. I gotcha. Oh, nice. What'd you think of Wonka? My family tends to really love the original, Willy Wonka and the Chocolate Factory, and so we look side-eye at any of the new stuff. But my younger child, as a teen, really enjoyed the Charlie and the Chocolate Factory with Johnny Depp. I don't know about that, but because I'm all about the come with me and you'll be in a world of pure imagination. All right, so follow behavior, and then we would return a new, return new reaction follow behavior, and else we return null. Oh. The LSD tunnel, yeah, the creepy LSD tunnel. It's so weird and out of place in that movie. Yeah, I have become a fan of musicals since my younger child has gotten into musical theater. And since then, I've seen, some really moving performances, even by the local high school. So, yeah, good stuff. They did, local high school did Bright Star last year, which is a musical that was written, music by Edie Brickell and book by Steve Martin, actually. But it's got a lot of sort of bluegrassy music in it, but kind of a cool story. So yes. Follow. Just like these, I want to make sure to not do anything. Oh yeah, so I don't want to do these anymore. In fact, I probably... Ooh. So we may want to pass this through as well. I'll clean that up later as well too. But that whole, if we did done talking with a value, then it says it like goodbye or whatever. Yeah, my kids and I went to see Hadestown earlier in in the fall. That was a pretty good show. Alright, so petting is all hooked up to this. I'm going to hook it up to the Gafen as well, since I just killed it all. And so we'll be sure that the Gafen signal works. So I broke something. Warning, warning, warning. That's the only problem with all those warnings. They hide the... Okay, converser. Signals... Oh. I commented out too much. At least I only commented it out. Converser I need. Converser I need. Petter I need. Anyway, if you guys want, I can keep going late tonight again. I think that worked out pretty well last week. I can go at least a half hour late if we want to see actual perception events come in and do something with them. We're pretty close to being able to do that. Because I think I can hook up a signal handler to the dog, generate a perception signal for adding a 24-hour stream. I can't do that. This past week, for whatever reason, my soft palate, the top of my back of my throat, or top of the front of my throat, I don't know how you call it, back of my mouth top, has been really inflamed. I can't eat anything acidic, and like at the beginning of the week I was having trouble swallowing even. It seems to have gone down a bit, but I don't know if it's allergies or if I've got some other throat ailment. What's the donation goal for that? A 24-hour stream? I don't know. You'd have to negotiate that with my family, I think. Yeah, too much pets. Actually, these days, after about 2 of them, I start to taste the lemon lime that they put in to kill the aftertaste, and that's all I can taste. All right, so talk should still work. Boink, it still works. Okay, we didn't break that. Oh, you know what? It's always dark. Let me turn on things so you can see. We should be able to place a dog. Okay, so if I pet the dog, he should follow me. Oh, there he goes. He's following me. Wait, why aren't you? Yes, there you are. Okay, so petting works. He got the signal and he started following me. It's kind of cute. Yeah, I don't know why. Oh, maybe he's trying to walk around the grass. I don't know. That's weird. But cool. Oh, yep. So he gave up following me. Cool. So that all works. I can't actually. I mean, time rolls on. Time is embedded in the server. So the next few plays, if we look at it, it will roll time forward, and we'll start it, and we'll have like we'll have daytime startups, but time is encoded into the world and constantly marches. When I pause it here, I'm only pausing my view. In fact, the time in the world never changed. This is only changing my point of view in the client. And I have not added a way to like set that on startup, like in a debug setting or something. It would be nice. But you'll see, yeah, so this is kind of like the precursor to a photo mode, right? Because in a photo mode, you might want to set the time of day and the weather and stuff to get the exact photo you want. So this isn't actually affecting the game time, except for it is in the sense that all of the environmental effects locally are based on this. So the day, sky and clouds and stuff would be affected. Well, maybe not clouds. Clouds would be set by the server. Yeah, clouds is a whole other thing I think about all the time. So anyway, there's the guys doing their thing. We hooked up signals. I'm willing to keep going as long as you guys are on. Well, not as long as you guys are on. As long as you guys are on, I'm willing to keep going for another half hour or so. Let's see if we can get perception sets working and perception signals going. So then, as part of this thing where we check for a heartbeat and add heartbeat signals, we also want to do perception checks. Add perception signals. Yeah. The idea being, if you have a heartbeat, you should add it first. It could be that I decide that perception checks should supersede heartbeat, but I really want the heartbeat to be regular and then let the AI decide to ignore it or not based on the current behavior. But anyway, the other thing we could do is check to see that we got all those signals. NPC signal, dog signal, yeah, so we pet it and so forth. I didn't check the Gaven, but they're wired up the same, they should work. So perception set is constantly, the perception set is called by the agent driver, right? Yeah, perception. But yeah, we've become big musical fans in this house in the last couple years. My wife always was. I was like, why can't they just get on with the plot? Why do they have to sing about it first? But I've grown accustomed to it, and sometimes it really is the case that as a musician and as a music composer, sometimes there's more emotion in the music and dialogue than just in raw dialogue. I find I get swept away a little bit more, especially on repeat viewing. With the high school shows, I go I go to all of them that my kid is in, and so I get to see also kind of like the show come together in 5 shows. By the end, it's a kind of a different show than that first show, which I think is interesting on its own. But also, I find that by the last show, I'm also completely swept away in the music, the emotion, everything. It's always the last show that hits me the hardest. Because I already know what's coming in a way, and I can get into the music. I don't know, it's hard to describe. But yeah, I've gained a new appreciation for it recently. Okay, so we want to we want to say, in fact, I'm just gonna grab it so I can agent get perception set, so I don't have to type the whole thing all the time. So what do we want these methods to look like? Well, first of all, we really want to say, what is the perception set keeping? It is keeping rigid bodies. Yeah. So if we say I kind of don't want to have to. Oh, apparently I already have anyway. Okay, so I kind of don't want to have to bring bodies into this, physics things into it, but okay, so body equals perception get entered. Then get exited. These are methods we'll have to write, by the way. And perception clear. That's not what I want to say. I want to clear the entered and exited sets because I already know about them now. Clear state. We'll just yeah, clear pending state. We'll call it that. Okay, so we have 3 methods to implement over here, which I'm just going to pencil in at the moment. Iterable, rigid body, blah blah blah. So that's the other thing, is like I have these weird habits of how I cut and paste code, and the IDE fights me every single step of the way when I'm doing that, because it's constantly putting brackets in where are normally helpful, but in the case of actually, let's make it return Boolean if it does, just in case we ever want to know. Anyway, yeah, like when I'm doing these weird cut and paste tricks where I, duplicate code 10 times and stuff, the IDE is fighting me every step of the way. It's really annoying. And I apparently do a lot of that because I get very annoyed very often. Okay, so for each one of these, we generate a signal. Signals, add new signal. What did I call it? Let's just call it entered view, and then the body. And it's not add. It's not just add. It's yes, it is, isn't it? Single queue add. Yep, I was smart. I made it a real queue. Okay. Exited view. Okay. So now, presuming perception set works, we are, dealing with, we're making the signals. We could add handlers if we wanted to, but let's go over and fix perception set to keep track of this stuff. So we want to keep track of the bodies that have entered the view and the bodies that have exited the view. So we want 3 sets of these. And perhaps we actually want maps. I will cross that bridge at a later time. Okay, so we want a set of bodies that are in view, a set of bodies that have entered, and a set of bodies that have exited. Okay, and so then for here we can return entered, return exited, and entered, clear, exited, clear. And actually, I believe that set clear, which one of these windows is my Java? There it is. I believe that collection clear returns a Boolean form. Nope, never mind. We will not do that either then. Because it's just a waste of time to check. Okay. Entered clear, exited clear. So every time we find a body in our results, we can say, so if it's, we want to keep track of what we want to do here is say exited, like basically all of the current results are potentially exiting, right? If they're not in this, we made a query to the physics engine to say, hey, give me everything that's intersecting the frustum. And so those are all the new ones. Potentially everything in view is now gone. We don't know until we go through the list of what's in there. So what we'll do is in here, we'll say if in view add body, that means it's new and it entered. Else, so that's else, not just else, exited, remove body. Okay, so if it's in view, it's not exited. It either is entered or it's basically this is a kind of a convenient way of, if we had anything that was already in exited but now is in view, we'll have removed that. But also because we added all of our previously in view to exited, we'll be removing that. Anything left in exited was in view at one point and is no longer in view, or was exited state that we didn't handle yet. Got it? Got it. Okay. So, agent driver is calling update for us. And then we can get, so this is all hooked up. Signals are hooked up. And all we have to do is add some behavior. And these are new behaviors. So we could, actually we are going to see, since all these signals log every event. Actually, I'm surprised. Oh yeah, that's why we saw this signal twice. So we should see signals for everything entering and exiting. And I need to actually like tame these. So let's make it so if a dog sees all right, let me think. So if entered view equals signal get type. Okay, so something new entered the view. Realistically, we want to see if we've already run to them recently. But maybe for now we could just make it say something. Let's just make it bark at the where's my example of saying something? I think I just have a say. Yeah. Okay. So bark at signal. Okay. So rigid body entity ID and block shape body equals see, there's another case where the IDE would have screwed me up because it would have put the parenthesis in and I'd have to go back and remove it. Body.id. Okay, so now we'll bark at whatever newly enters its view. In theory, let's see if it will compile and run. And we're getting closer. Okay, 792. Oh. Now the IDE would have helped me there. Not gonna lie. Ruh-roh. Oh, abstract body. Yeah, that's true. So all this needs to be yeah, because we even detect we even detect static objects in our view. And so we need to be a little smarter about this. For now, I think these are going to be two different signals. Okay, we can get away with just this because everything else is untyped, I think. So this should let us compile. Oopsie. Entered. Okay, I forgot to change one other thing because you all are watching. Oops. Alright, let's try again. Please try again. Boy, I appreciate that you guys like the long haul here. This is kind of fun. I found last week I was more productive in the last half of that 2-hour stream than I was in the first half, so I was all hyped up to code the rest of the night when I finished, and then I had to eat dinner. I watched a guy talking about how to be more productive during the day and so on, and he had like 5 tips. Yeah, the code zoom. He had like 5 tips, but he said the last tip was so effective that it might make the other ones like irrelevant because he got small improvements from the other ones, but the last tip he had was that he stopped eating breakfast. And I had recently discovered that when I skipped breakfast I was more productive because as soon as I eat that first meal of the day I get really sleepy. Yes, it's already brighter out when we start because each time it'll be a little bit later in the day. Uh-oh. Okay. So anyway, I've taken to eating later and later, and so sometimes now I don't eat any lunch at all. Alright, so we're getting signal from all... Oh yeah, because they're going to get the signals and not ignore them. Who's exiting the view, though? Everybody should be pretty static. Alright, so... exit view. The same thing keeps exiting over and over again, even when we're still in the view. So let me confirm that, right? Because we can turn on the... So if I'm standing right, stop moving. So if I'm not standing in anybody's frustum, I should never be even entering, let alone exiting, right? So if I'm way over here, They should see each other right now. Exited, exited, exited. I'm exiting all the time, even though I've never... Oh. Oh. One bit of cleanup I did not do is that I don't remove the exited values from in view. So over here in the perception set, this is the one thing I forgot. So we potentially say everything that's currently in the view is exiting, right? Anything that we add to in view and is actually added is an enter, and anything that we are, so basically these are the things that are actually currently in view, as according to the physics engine. In view is what we used to think was in view, and so we say all those are exiting potentially. As we add new things to in view that are brand new, we know those are entering our view because they weren't in there before. And else, if it's seen, then it's not exiting either, right? But what you also need to do is then, once exited is only the things that are exiting, we need to in view remove all exited. Otherwise, what happens is every time anything that was ever in view looks like it was exited. So that should fix that problem. And we can confirm as soon as this is done. Okay, let's confirm. And then maybe we can implement a real behavior. I'm not sure. I think I have a walk to behavior. So we could have the dog run up to anybody he sees. Should be kind of cool. He's going to be a nervous dog. And see, having a heartbeat signal, which maybe we can get to tonight too. Having a heartbeat signal gives us an opportunity to randomly break out of a behavior too. Which could be, whoa, that was weird. Okay. All right, so they should mostly be, so I should be entering his view. Well, I can't because he's walking too fast. So they just entered each other's view. They exit each other's view. I could have them talk. I could have, you know what? This would be cool. We could have them say hello every time somebody entered their view and exited their view. Anyway, the dog will bark at us. So let's go ahead and place the dog here. Okay, the doggy doesn't see anybody. Oh, he is barking. He's barking at... Oh. His limit may not be set up properly then. Oh no, he can see that far. Yeah, so he just barked at both of them. If he wants to, he can bark at me. Yep, he just barked at me. I'm entity ID 22. So he's... Yep. I just move back in. How often does he update his perception? Okay, there he goes. There could be some bugs in how the frustum thing is working. But also the perception sets are only updated 5 times a second or something. So that means that the exiting would only update 5. Yeah, so he's... Okay, so... Yeah. Let me see. Yeah, so I'm actually in the view before I think I'm in the view. Okay, move back over here. Yeah, see, he already sees me and I'm not actually in the... Oh, wait. I am actually in the view. Because I forget my bubble. It's using my bubble. There's a certain amount of slop, but basically he sees me. When I move into his view, he barks at me. And so we could have him come running up. I think if we set the behavior to walk to, and then not follow, we want him to run up. What do I have a walk to? Maybe it's in the behaviors. No, I thought for sure I had a. Maybe it's a steering behavior. Steering primitives. Yeah, arrive. So we want to hear for the doggy when he barks at us. We want to create an arrive behavior. Arrive equals steering primitives arrive agent. The location would be the body, location, position. Is it position? Yeah. And within 1 meter, that's fine. Okay, so that's what we want him to run. And we want him to do that. Steering primitives. What does arrive look like? Okay, so we want him to do that as long as that primitive is active. And I don't think I have a... Oh, see, this is close. It just keeps going, and what we want is... we want something like this. We want... Let me steal this code. And... we need to make an arrive behavior, but I'm going to hack one in right now. Yeah, it's ugly, just hold on. We're going to say... behavior equals new abstract behavior, and it's going to want... does abstract behavior want anything? The brain. This. Alright, and but in order to know... No, we're just going to use... yeah. This is straightforward. So actually we're going to want to keep the on start mostly. I don't think we care about the default action. I think we'll just set that to idle. And then we'll set the steering to arrive. And on update, yeah, we don't care about that. We just want to say we don't want to set the target all the time. Oh, steering primitives can't tell me when they're done. They don't know. So that's why we need conditions to check. It's actually kind of a problem with how the steering primitives work with respect to the behaviors. They're stateless in a way, so they can't tell you when they're done. And so we do actually need a lot of we do need some state gathering. So we have the body, double distance squared equals body dot position distance squared brain dot get agent dot. The agent should have a location. Is it the agent driver? Yep, get location. Okay, so the distance squared. The cool thing about distance squared is you don't have to do a square root, and if your threshold's 1 meter, well, that's also so we're done. If we've achieved our goal, we're done. And so otherwise we return true, and the IDE would already be telling me that I could combine all this into one. Okay, and then on stop we don't need to do anything. And so we can there we go. Whoops. Oh yeah, I don't need that. Okay, so we've created a behavior, and what we want to make sure is that the dog only runs in our direction for a certain amount of time. And so we'll also limit the behavior. I think we have these behaviors limited. Yeah, so we can just limit it to a certain number of seconds. So we will return new reaction behaviors limited behavior for 5 seconds. So he'll try to run to us for 5 seconds, and then if that doesn't work, he loses interest unless we enter his field of view again. So he barks at us. In fact, since there's those 2 NPCs walking around, oh, you know what? We can just go someplace where they aren't. So let's see if I've screwed up the compilation. I certainly have. In 100 really, really good way. Oh, okay, so we, yep. So all these cases of brain, I can just call get agent because I am the brain. Let's try that. Okay, so where's the actual error? Right, error cannot find a symbol. I think that these steering primitives, it's a public static class. Yeah, okay, so. La 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 la. Okay. Let's try again. Please try again. What was that? Here we go. Watching my CPU dive up to 100%. Okay. See, bright day. I actually, so, hello doggy. Did you just come running up to me? Oh, there it goes disappearing. Okay. I actually think this turns out to be a pretty cool outfit that she's got on. It's a fur shirt with the shorts. I don't know. Anyway, all right, let's plop the doggy down. Whoa, they can still see me way over here. Okay, so let's go. Let's go over here and plop the dog down. And he's going to be facing that way, I think, so let's get him facing. Yep, so he can't see me. He can't see me, but when he does, come look at me. Look at me. He comes running over. Hello, puppy. Okay, that was cool. All right, let's try again. Okay, look over to the other side. Okay, now come over here. Okay, look at me, puppy. Come here. Come here. Look over here. Look over here. I'm bouncing up and down in my chair. I love it. I like it. Okay, so let's make chaos. Let's put a dog over here. And we'll make chaos. Yeah, so he's going to run over to these guys. Oh, he doesn't know where to run to. That's the other thing, is when he's running to somebody, we shouldn't necessarily have him interrupt. Aw, he ran right over to them. He's a good doggo. Hello, doggo. Hello, doggo. Actually, let's give him a home so that he'll wander random and catch people in his view that way. Okay, come on. Turn around. I like see the view for us from over there, too. Oh, hello, doggo. Come here, doggo. Yeah. Oh, yeah. Hello, doggo. Yeah, yeah. Okay, what are you going to see? You going to see them? Okay, go see them. It's so dumb and stupid, but it adds everything, right? He does his thing until he sees somebody. Now, the key is to give him a little bit of memory so that he can remember that he already ran up to us. But that's really cool. So this is the basis of all kinds of complex behaviors that are coming up. So I'll formalize this a bit. And I think what the next thing we're going to work on is... so, hello, doggo. Let me... I think I can show... So, once I get the AI straightened out, which will kind of be an endless process, but I think we're right on track. There's a whole lot of custom code I can delete now. I didn't get the... Okay, where it's already like 40 minutes over my normal end time, but I didn't get heartbeat signal working. But that's the last thing. The heartbeat signal is the last thing I need, really, to re-implement all these AIs with the new way, and then I can externalize them into scripts, which will be cool. But that may actually be for next week, because what I want to work on my own time is what I want. So here's my ultimate goal, right? That when you come and you chop a tree, a chunk gets removed right there, right? If I chop it up here, a chunk gets removed up there. Or if this is a pickaxe and I chop into a stone block, it chips out a stone right there, and if I chip out enough stones, the block goes away or turns into a smaller block. So that you can basically chip away at these blocks and retrieve resources from them. So unlike in that other Block World game that everybody plays, that 100 million people play, where your unit is a block, in Mythruna a unit is going to be, I think, probably a 16th of a block or something. So when you if you kill a whole block, you get like like if I killed this whole dirt block, I'd get like 64 units of dirt or something. I can't remember what I really want to do there, but that's sort of what it is like there's this you know, 1/64th of a block chunk that really each of these represent, you know, that you can, so you get 64 if you take a full block. Although this would be maybe multiple materials that you would get out of that. If you were using the wand and you get rid of the whole block using the build one, for example, you know, so if I was to do this, you know, I would get 64 units of dirt, or, you know, some number of units of dirt, and maybe, depending on how I choose to break down raw materials that get stored in the wand, you get like 64 units of dirt, or maybe 60 units of dirt and 4 units of organic material. But that's the thing, is if you break things up that way, you miss out on some opportunities. Like if there's stuff that you could retrieve from the dirt, then you should really use a shovel to chip it away so that you can find those things. If you use the wand, it's going to destroy stuff. But for building, obviously the wand is super convenient, and the wand will regurgitate eventually, right? Wands is unlimited right now. I can place whatever I want without ever having to retrieve anything. But eventually the wand will only be able to place what you've collected the resources to replace, and those will all be stored inside the wand. And so there'll be certain types in the game mode, there'll be certain types of blocks that you can't create with the wand. You'll have to build them, kind of thing. But anyway, that's yet to be determined. Initially, things will continue to work like they do, and I'll you know, have the ability to chip away at stone. But in order to do that, what the other topic of tonight's live stream would have been, if we hadn't worked on the AI, was going to be figuring out a way to keep track of if I that's not what I want. I want to run block it. So what I'm talking about is, you know, like in Blockhead, if you place down a full-size stone, see, this is kind of like a reward for you guys hanging out. You get to see what I'm working on next. So if you pretend this is a regular block in Mythruna, you know, ignore the fact that the texture is multiplied by 4. But you know, if this was a normal block in Mythruna, and you start chipping away at it with the axe, you know, you get like these things. But I want to be more interesting than that. I want to say, if you had, let's say this is the full-size block, right? Or this is basically I want to know if for this block, like say this, so this is one of the little blocks, but I don't want it to just work on cubes. I want to know that if I chipped this here, that maybe it becomes, was it a wide wedge? Wide wedge. Right, so if I hit my pickaxe here on one of these little blocks, then it becomes this block. And if I hit down here, you know, then it would become the half block. But if I hit up here again, up near the top again, it would become a wedge. And then if I hit that again, then it becomes, basically I want to know sort of the volumetric shapes in such a way that if I say I want to remove this area here, and you find the closest block shape that matches that, which in this case would be this. That's the closest one we can get if I'm just removing there. And if I remove it again, this is the closest shape we can get. And if I remove this down here, perhaps the closest shape we can get is the you know, narrow wedge. Or if I, anyway, there's different. So I have an idea, I have a theory, and that's what we would have worked on tonight, and maybe we'll work on it next week depending on what the AI is, or we'll work on it this weekend. I don't know, and I'll just get to show you guys. But where I consider these as like a bunch of balls to figure out like sort of their shape signature, so that I know if I was to remove one of these balls that the closest match I get is this, because I could compare like the binary signatures of these. And anyway, the long and the short of it is that I don't want to break up with the chipping. I don't want to break up blocks into cubes. I want it to automatically sort of figure out what the best one of these shapes would be. No, not on this. Not in this engine. The closest I will get, I will tell you, when I go through the beautification pass, what will happen is, in addition to having better grass, what will happen is I will round over these edges so that they look rounder. But everything will still be block based. That's sort of fundamental in the engine right now. And while I could do smooth terrain, that's just a whole it's a whole deep maze. It's a whole rabbit hole to go down that distracts from implementing the game. I can do everything else and come back and make a Mythruna 3 someday that has smooth terrain and still get to keep almost every system I develop. So I'm trying not to be distracted, because that happened last time I made the game. I got distracted by 100 things. So this one, I'm trying to get to the point where we can go and down in dungeons and kill stuff and collect loot. I think you all agree that that would be fun. I hope. And then like the stuff you build, have impact. Potentially be able to set NPCs to work building things for you, that kind of stuff. Construct your own towns. It's all the cool stuff that I want to get done, that can still get done with Block World, and would be a year or two distraction if I went down the isometric or isosurface terrain. But I have done that before. If you check my YouTube videos, you can see all kinds of stuff where I did smooth terrain in all kinds of different ways. But anyway, that's I think where I'm going to end it. If there's any more questions, I'll pause for a moment for final words, final thoughts. Otherwise, I hope you all have a tremendously productive week if you're working on creative projects. If you're on the Discord, please share, if you want, what you're working on. I think we'll all be interested, because we are all creative people. I think that in order to be interested in a Block World game, that you have to sort of be creative, since at least part of the fun is making stuff, right? And Mythruna hopes to tap into that by letting you make anything, your items, your clothes, etc. So hopefully that resonates with people. Anyway, once again, up here in the top left is where you can download the latest version, which is from January. And I will thank everyone. Thank you for joining and sticking with me for this extra 48 minutes. And I will also thank the patrons one more time. And go ahead and sign off for the night. Again, have a productive week, and I will see you guys online. Thanks so much.